All right, so 5.2 is going to be a section that begins our application of the angles that we've been learning about. There's a lot of different applications of angles, okay? The first one that we're going to talk about is arc length. And we've already seen arc length when we were talking about the definition of an angle in radians, right? An arc length is basically any distance you travel around the circumference of a circle, okay? Any distance. It could be a part of the circumference. It could be the entire circumference. And even it could even be several pieces of the, you can go past the circumference more than once, okay? So the arc length is just the general term for any distance that we travel around a circular path, all right? Now here's the formula for arc length. But wait, let us review, okay? Remember the definition of a radian. The radian measure of an angle was theta equals S divided by R. It was the ratio of the arc length to the radius. And do you remember why we used S for the arc length instead of A? A was already taken, right? A is usually taken for area. So why did we use S for arc length? The British, maybe, or the Greek, or no one knows for sure, but pretty sure it was the Greek, right? Eratosthenes, remember he measured the circumference of the earth by using shadows. Their unit of measurement was the stadia. Stadia being their length, stadia starting with S. And then the British were like, nice. So they did get involved. So, and this tells us why the angle is unitless, because we measure arc length and the radius of the circle in the same units, right? Both in feet, both in miles, both in inches, and they do what? Divide out. Very good. Now, if you simply take the definition of a radian and you multiply both sides by R, you get S equals R times theta. And guess what? That gives you a formula then for the arc length. So let's jump down here to the definition. If theta is a central angle of a circle whose radius is R, where theta is measured in radians, unitless, then the arc length S is given as S equals R times theta. Pretty simple formula, R times theta, right? You got to have it memorized because I'm not going to give it to you on the test, which is when? This day. Wednesday. Let's try it out. Example 1. Find the distance that a runner travels in miles along a circular track that has a radius of 5 miles if he runs through an angle of 300 degrees. Not through a temperature of 300 degrees. That would be like, dude, stop running. You're putting your life in jeopardy. Through an angle of 300 degrees. Now, how many tracks do you know are perfectly circular? The one that we have out here around the football stadium is more ovicular, right? But if you don't know any circular tracks, then you certainly don't know this one, because this one says it's circular. And it has a pretty large radius. So I always imagine like this being a track around a city, right? You have a city that's inside, and then there's this perfectly circular track that goes all around the city, circumscribes the city, where you can go jogging, you can go rollerblading, you can push a stroller, whatever, right? A healthy city. Well, this dude is running around this track, and this track, by the way, has a radius of 5 miles, okay? So we're going to call this 5 miles. Now, this dude doesn't even make it all the way around. He doesn't even run lap, because he only runs 300 degrees, right? Now, before you make fun of the dude for not being able to even run one lap, jog 300 degrees in his shoes, right? Because it's a big lap. So the first thing you might want to do after you draw the picture is superimpose upon it the X and Y axis, all right? So I'm going to let the Y axis run right through the middle, and I'm going to let the X axis also run right through the middle. Now, we don't know where this guy started running, and we don't know if he ran around clockwise or counterclockwise from our perspective. That doesn't really matter. So if it doesn't matter, let's go ahead and orient it in the fashion that we prefer. Let's go ahead and let the dude start right here. He's going to start on the positive x-axis, just like we do for our initial ray. From there, let's let him run. What do you want him running? Up or down? Okay, up. That's the positive direction. So let's go ahead and let him start running. I'm going to have his footfalls be this color. So here he goes. He's going to run, right? Little zigzag here. That's kind of his footfalls, right? So he's running. He's running kind of fast, right? But really, it's just filmed and played in fast forward motion. Like, have you ever seen old videos of like Babe Ruth when he ran around the bases? It's like, how can someone so fat run so fast? Well, they sped up the video. So here he is. He's running through 180 degrees, right? And he's still running and running and running and running to 270. And then running and running. And then like Forrest Gump, he just stops all of a sudden. I think I'll go back home now. So there it is. He runs through 300 degrees. He doesn't even make it a full lap. Okay. This that I shaded in little zigzags, that's the arc length. Okay. And I want to figure out if he runs through 300 degrees on a 5-mile circular track, what is that distance? Well, is it as simple as just saying 5 times 300? I don't think so. Let's go ahead and pull out the handy dandy formula. S equals R times theta. Now, one of the most important things, if you're not quite sure about what you're doing, is to try to include units for these applications. Try to include units as often as possible, because the units are a good way to check the math. If you get to your final answer and the units make sense, then more than likely you set it up and evaluate it correctly. But if the units don't make sense, then something's off, right? So if you did just merely plug in, the radius is 5 miles and theta was 300 degrees, okay? You multiply and you get 1,500 miles degrees. What the heck is that? If you're bragging to your friends, dude, I got it this morning and I ran around the city. I didn't make a whole lap though. Really? Well, how far did you run? I ran 1,500 miles degrees. And they're like, whoa, you need to see a doctor or run in cooler temperatures because your brain is fried, dude. You ran miles degrees? What does that even mean? He's like, I have no idea. I didn't pay attention in math class. I'm just running and running. I thought the formula was R times theta, radius times angle. That's what I did. But oh yeah, you know what? There's another way to measure an angle that is unitless. And that's called the what? The radian. So why in the heck do we need radians for problems like this? Whenever you're dealing with something that's rotating and it involves distances or lengths, you got to use a radian, because otherwise people are going to think you're sick in the head. Miles degrees, I run it and run it. Now, we need to convert 300 degrees to radians. So you can either go off to the side on your workbench and convert it there, or you can convert it directly in the problem. That's what I'm going to do. Expand that out. Here we go. I'm going to put this over 1, right? So we can see a ratio. And just like we did yesterday for the warm-up, we're just going to convert it. I want the degrees to divide out, so it has to be from high to low. And I want the radians to appear, which is only a description. So I'll put it in the numerator. And now it's just either pi over 180 or 180 over pi. It's one of the two. What's it going to be here? Pi over 180. Yeah. And now you can see clearly that your degrubbles divide out. And now you're left with units of miles times radians. And now you can tell your friends, hey, I ran around the track so-and-so, blah, 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 miles, radians. And they know your sense of humor. And so they're like, just, I get it. I get it. Just miles. Because what is miles times radians? Miles. Because radians are not a unit. They're just a descriptor. And so your friend knows how funny you can be. And they're like, I get it. Okay, miles times radians is just miles. Right, right. Now let's see what the answer is going to be. This is where we pick up the calculator now. 5 times 300 times pi divided by 180. So let's go to the calculator and turn it on. There it is. Clear it, flush, right? Now we don't have to worry about the ones because multiplying by 1 and divided by 1, same thing, right? Identity element. So let's go ahead like we did earlier and leave pi visible because pi is a irrational number. And if pi is in the calculations, I might want it to be exact. So let's do 5 times 300 divided by 180. Boom. Now that's 8.4ist, right? 8.4ist, right? Your friends know your sense of humor. Oh, 8.4ist is 8. Tree, right? So that is a rational number that will convert. How do we convert it? Math. Enter, enter, boom, boom. So I could write this as 25 pi thirds. And then what are the units going to be? Miles times radians or miles. All right. Now, the units make sense, right? But if you told someone you ran 25 pi thirds miles, they're going to be like, where do you live? Right? Who talks like that? So in this case, we're going to want to actually multiply it out. Please rise for the pledge. United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. So in addition to the exact answer, to help people make sense of it, including you, go ahead and multiply it out. 25 divided by 3 times, and then use the pi button. That gives you 26.179 miles. And that makes a little bit more sense. Now check this out. He didn't even make a full lap. He is so close to running the distance of a full-length marathon, which is 26.2. So yeah, wow. He got distracted at the end, like I sometimes did, right? Free beer, right? Pet some puppies this way, right? And you get distracted. So pretty long way. Didn't make a full lap, almost a full marathon. Way to go, bro. Would you move to this city? I would. And I would host a yearly marathon called 301 degrees around the city. Yeah, that would be the name of my marathon. All right, tomorrow we'll pick up where we left off, and by tomorrow I mean Monday, because I always forget what day it is. Y'all have a great weekend, and listen to the rest of the announcements.